problems. All right, so we are going to evaluate integrals again today. But this one's going to be a little bit different because we are going to change the variable. We are starting with an x here, and we're going to end up with a u. And then when you change the variable, how do you adjust for that when you change the variable? Okay, so first thing we're going to do, they tell us what u is in this first one. U is 2x squared plus 1. So if we wanted to rewrite this whole thing, this would still be the integral from 0 to -1 of negative 8x u cubed dx. All right, and then, as it says, u equals 2x squared plus 1. Well, what would you do normally in this situation from here? What do we have to find next? Yeah, we got to find the derivative of u. So u prime would be 4x dx, right? And then what do we do with that? Yep, we divide our original by that derivative. Okay, and that's still the case. We're not going to change any of that at all. So what we have now is we have the integral from 0 to 1 of, when we divide this out, we get -2 u cubed. And now this, instead of it being a dx, this would be a du. Now, I haven't made a big deal about it, and it's really not that big of a deal, but that's how it should be written at this point. Okay, now, if we leave this in terms of u, we have to change these restrictions. Okay, how we change those restrictions are, first of all, we're going to plug the 0 in to the u equation where we see an x. So when we throw a 0 in there, we get 2 times 0 squared plus 1. That just turns into a 1. So when we're actually doing this integral, we're going to evaluate it. Instead of a 0 being on top, we're going to have a 1 on the top. Then we're also going to put a -1 into that. So 2 times -1 squared plus 1. Looks like we should get a 3 there. Okay, and then we would just integrate this part. Okay, so whether you want to do this in your calculator or you want to do it manually, it's kind of up to you. Okay, it doesn't matter which way you go from here. I'm going to do it by the calculator. So I'm going to change this back to an integral sign. And then we've got 2 u cubed du. Now, when you're using the calculator for this, okay, we've already changed our 0 and -1 to a 1 and a 3. Okay, when you type in your calculator, you can put a u in there if you want, or you can just put an x in there. It doesn't matter which way you go there. And then you just type it in exactly the way it says there. And what do we get for an answer? If you're not typing it in the calculator, you're doing it manually. What do we get? You got 40? That's what I got. That's what you should get. All right. Ethan, thanks for coming. All right, so this is just another way to attack these sorts of problems, okay? Integrals are a little bit easier than what we would have had to have done doing it the other way, okay? For these, honestly, it doesn't matter which way you go. You can either do it the way we're doing it today, or you can do it the way we did it previously. Both ways work for this. There are going to be other situations, though, where you change your dimensions. And when you change your dimensions, you need to switch it from the one variable, so like our x here, to our other variable, which was a u. Okay, so we're going to go through number 2 here really quick. It is kind of nice that they're telling us what u is here. All right, so we have got the integral from 0 to -2 of 4x over u squared dx. All right, as we said before, our u is x squared plus 1. We got to find u prime, which is just a 2x dx. And we're going to take our u prime and divide this whole thing by that. So 2x dx. When we do that, the dx's obviously cancel. 4x and the 2x turns into a 2 on the top. So this would be 2 over u squared, and then this turns into a du. All right, and then we just got to find our new integration points. How do we find those new integration points? We're plugging our 0 into our u. So we've got 0 squared plus 1, means that that ends up being a 1. And then we plug in a -2. -2 squared plus 1. Looks like that would be a 5. All right, and then that just becomes a calculator exercise from there. All right, so go ahead, get me an answer, please. What do we get? 8/5. Positive or negative? Good question. All right. It should be -8/5 if you do it this way. Okay, I mean, if we were to just keep it all in terms of x, so we get to this value, and then we take the derivative or the integral of this, and then we plug back in our u, then we would still have to have a highest over the lowest. But when we change the variable, we don't have to pay attention to that. Okay, and so that was an extra step that I left out on purpose. Okay, so when we change the variable, you just type it in exactly the way it is. Whatever the answer comes out as is your answer, okay? If you don't change the variable, then as Ethan said, you do have to pay attention to that. If the biggest one is on the bottom, then you're just taking out the value of it. Okay? Questions at all? All right, you guys do both of these. Both of these are just like the last two. Eli, you really huffing at me with a whole 3-slide lesson today? Yeah. We're getting close. I did tell Mr. McKinney, though, that I had an 1.5-hour lecture for you. I can make these last 2 slides into another 1 hour and 16 minutes. You want me to try? No. You all right, Jacob? No. Track team's now sick too.
Track team's not allowed to be sick. Because if you're sick, you're weak mentally.
Is that fact?
Please ask Mr. A, you know.
Are you actually serious?
Pretty much.
We get an answer for number 3.
So,
What do we get?
3, 7, I mean.
Which one? That's what I got also. All right. Get number 4 taken care of too. The next one is a little bit different on the next page, so we'll run through that one together. You guys got number 4?
4, 3, 2.
What's the first thing just putting that into our calculator?
Nothing. It's just another way to do the problem. That's all. And it really, Ethan, as I said, when you change the variable here, as we changed it to u and we left the u in there, you have to change the restrictions on it.
Yeah.
Okay. So you're going to see this, especially engineering wise. You're going to see this where they change the variable coming up pretty soon. So then you just have to apply this rule at that point. Okay.
I'm gonna be a lawyer
Oh,
now.
well, fine. Be that way.
Are you?
Probably.
Already, huh? Can't handle engineering. You haven't even gotten there yet.
I talked to Coach Boyd about it.
Why?
What did we get here for an answer, people? Negative what? 0.6? What did I do wrong up there?
Supposed to be 24.
Oh, I plugged it into the derivative. My bad. Wow. So this should be a 20 is what you're saying?
Yeah.
And then bottom one was right? All right, negative 0.6. Very good. All right, any questions at all on those 4? All right, next one. Gentlemen, let's go. Last one here. This one is going to be different. I know it doesn't look like it, but it will be. All right, so write this down. You think so? Did you check that already? Close, not quite. What is 1 minus 2?
Oh.
All right, so how we start this out, we started out the exact same way. So integral from 1 to -1 of negative 4x u cubed dx, and then we take the derivative of u, so u prime equals 2x, divide that out. We get negative 2 u cubed du. All right, and then we have to plug in our 1 and our -1 here. When we plug in our 1 squared minus 2 is -1. Throw in a -1, -1 squared minus 2 is also -1. Now remember, okay, think about this logically first of all, okay? Integral. One way to think about integral is finding area under the curve. Well, the curve, underneath this curve, whatever this is supposed to look like, we're evaluating from -1 to -1. What's that area going to be? It's going to be 0. Whenever you evaluate, and your restrictions are the same, you're not going to have any area to find there. So it's automatically going to be a 0 there. All right. So any questions with this change of variable thing? Okay. We will see this every once in a while. We might see this later this year when we're trying to find, say, for example, we're trying to find velocity. Okay, we start with the time, but then maybe we have to change it into a distance at some point. Okay, there's lots of different applications for this.